number 6. So write a program to obtain a greater, middle, and smaller number from three numbers. So we will be writing a function. We'll pass three numbers to it, and it'll return us smaller, greater, and middle number. So if the middle number is odd, then it will print coffee is of Starbucks is good. Else it will print coffee of Dunkin' Donuts is good. So that's pretty quick program. So what we're going to do is we're going to say define, right? First thing first, define is def, right? And then we say numbers. So because we need to take three numbers, so we're going to say num1 comma num2 comma num3. So these are the three parameters we need to pass to the function, and we're going to just use a built-in function to basically find these numbers. So you can use max, basically a function where you pass there's a number 1, number 2, number 3, right? And it will return you the greatest number, maximum. And similarly for smaller, we'll be using min function, which is also built-in function, and it takes three variables. So you pass number 1, number 2, and number 3 as a parameter, and it will give you the smallest of 3. So this is pretty straightforward. And then we obviously there's a challenge of middle number, right? So middle is a little tricky. So what we have to do for middle is, imagine you call this function number, right? Let me actually call this function here first. So I say I just call this function. I say m is equal to numbers, and I pass this, and I want this to return me the middle number, because at the end of the day I need to check on the middle number. What is the situation with the middle number? Because if the middle number is odd, then I need to print coffee of Starbucks is good, else I need to print coffee of Dunkin' is good. So if I pass, let's say 2, I pass 5, and I pass 1, right? I pass three numbers. So technically speaking, what will happen is that when I call this function, this 2 will go into number 1, and this will go into number 2, right? And this 1 will go into number 3. Okay, and I can easily get the greater, which is basically 4. It will return this function when I pass this to it, and same way smaller will return me 1. But I don't know which is the middle. How would I know middle? If I have smaller and greater, all I have to do is add these three up, okay, minus smaller minus greater, and we'll be left with the middle one. How does that work? So it's very simple. All I have to do is add 3 up, right? I say num1 plus num2 plus num3. Now all three are added, right? 2, 4, and 1. That would be what, right? Like this. It will be 2 plus 4 plus 1, right? So that would be what, right? That is basically if 2, 4, 1 is added together, and I minus from it greater, and then I also minus from it smaller. So what I'm left with then? Oh, middle, because it will be minus 4 minus 1, and we'll be left with 2 only. So middle will be the 2, and then all I have to do is return middle, and this is it. And then when I call this function, the value of m will be the middle one. And what I could do is I could say if m percentage 2, because I need to find out if the returned value, the middle value is odd or not. If it is odd, what I have to do, remember that the question, right? The actual question, if we go slightly up, if it is odd, what would happen? It would happen here. All I have to do is middle number. I would say coffee of Starbucks is good, else it will say coffee of Dunkin' is good. So it would say if it is odd number. So we can just print this message as it is. Okay, if it's odd number, print like this. Okay, it's just gonna print coffee of Starbucks is good. And if I else, what I'll do, it will print Yeah, what will print? Let's print this coffee of donut. Dunkin' is good. Okay, this way, and that's it. Sorry, here we go. All I need is, this is what the question asked me, so I'm gonna do the bare minimum, you know. So we should do what the question asks us to do. So, and is there anything else question asks us to do? I don't think so. This is pretty much it. So let's see. We enter three numbers, right? Not enter three numbers. We'll call three numbers. So let's say 2, 4, and 1. Now, is middle number, which is 2, right? Is that odd? No, it's not odd. So what would print? It would print coffee of Starbucks is, sorry, Dunkin' is good. Dunkin', because that's what I need, isn't it? Dunkin'. If you look at it here in the question, it says if it is odd, then print Starbucks. If it's even, then it's Dunkin'. So Dunkin', like this, right? Okay, so let's run this one. Here you go. It says coffee of Dunkin' is good. But if we pass here, let's say 35, here we say 29, and we say 28. Now which one is middle? Of course 28 is middle. 35 is 28 is last one, 39 is the highest one, 35 is middle. So is middle is odd? Yes, it is odd, so it will say Starbucks is good. Let's see. Here we go. Coffee of Starbucks is good. See, so that's how simple this program is. I hope you enjoyed it, because this is pretty straightforward, because you could use these functions, built-in functions, to write the program, no problem at all. And next one, let's go to the next question. We do the reload it again, and I'm gonna copy the next question, which is question number 7, right? Okay, let's do the question number 7. Okay, now best is to break the question down first, right? And break down the question. Write take a number from the keyboard. Okay, then write a program to check whether a number is palindrome or not. Okay, first we need to find out what palindrome is, and then what is last part. If number is palindrome, print what? Print coffee of Starbucks is good, else print coffee of Dunkin' is good. There we go. That's if else, right? Simple. And all we have to do is check what a number is palindrome. Now first we need to understand what is a palindrome number. Now let me explain you. If, right, if you do the number in a reverse order, okay, and it basically when the digits of any number are reversed, for example 1 to 1, right, when you reverse it, it becomes 1 to 1 as well, right? So any number that when it reverses digits, and it basically it's basically it's the same number, you know, so that is a palindrome number. So what are those numbers? For example, if I say 1 to 1 here, and you reverse all the numbers 1 to 1, right, it's still 1 to 1. What about 1 2 to 1? Still, if you reverse it, it's the same number. 1 2 3 2 1, that's also 1 2 3 2 1. If you reverse it, like for example here you put the 1 to 1 first, it reverse is the same number. Same, I think 0 to 9 are also the palindrome number, because you can reverse it. And then 10 is not, because when you reverse the 10 is equal to 0 1, it's not. What about 11? 11 is, you reverse it, it is 11, right? What about 12? You reverse it, it becomes 21, it's not palindrome, right? Similarly, you go, what is the next number which we reverse? I think 22. If you reverse it, it is 22, right? 23 is not, because 23 becomes 32, right? And the next one would be, I think 33 is equal to, reverse is also 33. What about next one? 44 is similarly 55, 66. So all these numbers, 101, 111, all these are palindrome numbers. So we need to find out how, if the number is palindrome number or not, and that's a bit tricky, because for that you need to write a function called palindrome, right? So I'm going to do that. I'm going to write a function def Okay, I'm gonna say palindrome, and I'm gonna pass a number to it, right? And then we're gonna check if that number is palindrome or not. Okay, so first thing we need to do is reverse the number using while loop, right? So we, whatever the number we, for example, if we get 123, we have to make it, how do we reverse? If we get 123, we have to reverse it 321, 321. That's what we need to do. So for that we use a while loop, and in a while loop first we do reversed, okay, number is equal to 0. We put it to 0, right? And then we say number, whatever the number you pass, we save it in a number, right? So that we can play around with it. So when we say while number, for example, if you pass 1 2 3, we say while number is not equal to 0, okay, do one thing, do you say digit, right, is equal to number percentage 10. Now that is a bit tricky, right? So what is percentage 10 mean? For example, if we pass 1 2 3, and I'm going to write it down here, by the way, 1 2 3 to the number palindrome function, and you say percentage 10, what is the result of this? Percentage 10 mean that you divide it with a remainder, divide it with 10, right? And you want to find out the remainder, it give you the remainder. So if you divide 123 with 10, what remainder you get? You get 3 as a remainder. Okay, and the idea is that you do like this, you get 3, now you get the first number, and the next thing you want to do is, then the next thing what you want to do, you want to use another function called which give you the divider, okay, and you want to get this reverse number, whatever the reverse number is, which is set to 0, right? And you want to set basically reverse number, okay, times 10 plus digit. So for example, reverse number is 0, you time it 10, multiply with 10, 0 multiply 10 is what? 0 plus you wanna add the digit, right? And digit would be 3, right? If this is a digit, right? If this is a digit, if you do like this, right? And that become the first reverse number will become 3, so you got 3 there. And then next thing you want to do is you want to divide number by 10 and get the divider, right? You want to get the divider of the number. So if the remainder was 3, what was the divider? If we say divider, like divider is like this, it gives you double this. So if you do this, the divider is what? 120 is 12. Divider is 12, isn't it? Because if you multiply 10 with 12, you get 120, and divided is 12, so it gives you 12. So now you basically save 12 in the number, actual number, right? And goes back, and number is still not 0, and then the 12 will be, then the digit would be equal to 12 percentage 10, and that give you 2, right? Because the remainder is 2, okay? And then you add this remainder to same formula, right? Which formula? The one I gave here. Reverse number is what now? Reverse number was 3, okay? 3 times 10, 30. 30 plus 2, 32. So now the reverse number is 32, right? Because it was 0, and now reverse number is 32, okay? So basically this is how it all goes. Let me write down to explain it better, I need to write down the whole formula. So you use the divider and the remainder to sort of like, calculate this. So we say reverse, okay, is equal to reverse number, and then we do times it 10 and plus digit. And then what we do, go further down and we say number this equal 10. You know what this mean? Yeah, this mean number is equal to number, this is 10. Now this give you divider, right? This give you divider. So if number is 123, remainder is divided by, okay, we'll come back to that. I'll do it one more time so you really can understand. What is next we need to do? We are in the while loop, so we're going to keep doing this in the while loop, right? So these three things are going to continue in the while loop, 1, 2 and 3, and it's going to reverse the whole number and save it in the reverse number. So let's basically start it here, right? Let's imagine you pass here, you pass 12, right? Let's imagine you pass here 12, no, 1, 2, 3, right? Let's say you pass 1, 2, 3. When the 1, 2, 3 comes here, reverse is set to 0, number is set to number, which is 1, 2, 3, right? And you say, well, number is not 0, which is 1, 2, 3 right now, right? Because this is gonna go into this, right? Then you say digit is equal to number divider remainder 10. So if we say 123, okay, and we say 123 remainder 10, what remainder will get? 12 times 10 is 120 and remainder is 3. So digit would be, what would the value of digit? Would be 3, right? And then we do is we say reverse, which is 0, okay, 0 multiplied by 10 plus 3. So what would be the reverse value? Reverse value would be 3. Okay, now 3 is in the reverse. It was 0 here, and now it's 3. And then you say number is equal to number, and this time you're gonna give you the divider, not the remainder, because this percentage give you remainder, this give you divider. So 123 divided 10 is basically 12, right? Because it give you 12, right? So number would be 12. Okay, by the first loop the reverse will be 3, okay, remember that, and number would be 12. So let's go the second iteration, right? So the reverse is 3, remember that, right? Reverse is 3, I'll write it down, and number is 12. Okay, I'm gonna write it down so we remember. It goes back and check if the number is 0. No, it's 12. Digit number is 12. Now here is 12, right? 12 remainder 10. What is 12 remainder 10? Is 2, right? It's simply 2. Okay, so now digit is 2, okay, and reverse is 3, right? 3 multiplied by what? 3 multiplied by 10. What is 3 multiplied by 10, right? 30, right? 30. And if 30 and you add digit to it, so what is digit? Digit is 2, this 2, right? This goes into digit. And if you add 2 here, that will add, it will make it 32. You know why? Because 10 multiplied by 3 is 30, okay? Because the reverse was 3 and multiplied by, this is 3, right? 3 multiplied by 10 plus 2, yeah, plus 2, and that would be 32, right? Now what is 32? 32 is the reverse number. Now value of reverse number is 32 now, remember that, okay? And what is number then? What was the original number? Number was 12, right? Yeah, this 12, and 12 divider 10, what it gives you? 1. It gives you 1, simply 1, nothing else, right? So now number is 1, okay, and reverse number is 32. Remember, 32 and 1. I'll write it down here, 32, so we don't forget. 32 and 1. Okay, now number is not equal to 0. Yes, because it's 1. So what is number? 1. 1 remainder 10, what it gives you? 1 remainder 10 will give you 1. Why? Because you can't divide 1 by 10, so the whole number is remainder. So digit is 1. What is reverse? Reverse is 32, right? 32 times 10 it will make what? 32 times 10 will make 320, right? I'm going to write down here 320. 20. What is digit? This is digit 1, right? And then you add 1 to it, right? So adding 1 to it would be equal to 321, right? And then you say number is equal to, now reverse number is 321, and number is equal to number divided by 10, right? So if number is, let's say, number is imagine number is actually what is number now? 1, right? Number is 1. Yeah, number was 1 actually when we started. So 1 divided 10 is basically 0, because you can't have a divider of 1. If you say 1 divided 10, you get 0, because 1 is small than 10, so you're gonna get divided 0 because it's just the remainder 1. And then it goes up there. Now number is 0, so is number not equal to 0 here? We'll check. No, it is equal to 0, so loop will break. So when the loop break, value of reverse number would be 3, 2, 1. So what did you enter? You entered 1, 2 and 3, okay, and it reversed the number 3 to 1, so it is already reversed it for you. Now what we need to do is, all we need to check if the number, original number, which was 1, 2, 3, is equal to the reverse number, then it is basically a palindrome number. But if it is not, it is not a palindrome. This one is not a palindrome number, right? So what we're gonna do, we're going to now check next if and that's gonna be inside the function. We're gonna say if, okay, number is equal to, and we could do integer, right? Because it's a reverse number, right? Reverse number, okay, number is equal to reverse number. Because the number is integer, so reverse number has to be integer as well to be compared, right? If that's the case, what we're supposed to do, we're supposed to print, what we're supposed to say, remember that? Yeah, what was that? This one. Yeah, Starbucks is good. That's what it's supposed to print. But if this is not the case, then we go into the else part, and what would you print, right? In the else part, we'll say Duncan. Yeah, coffee of Duncan is good. By the way, this is just an example, coffee of Duncan or Starbucks. You know, an actual exam, I may ask you to print something else. Here we go. Yeah, Duncan is good. And this way, we are done with the question, and that's all the question asks us to do, right? And now we need to take a number as an input, right? And all we need to do is call that function, right? And check if the number is palindrome. The question also says one more thing. Do you remember that on top here? What does it say? It says take a number from the keyboard, right? On top. So we have to take a number from the keyboard by the user, right? How do we take a number from the keyboard, right? We just use the input command. Remember? Input command. We just say number here. Number is equal to, and because we need an integer number, because we need to do a comparison, so we'll say this integer, and we say enter a number. All right, that's it. This has to be this way. After that, we just gonna call the function, and that's it. All we have to do is call the function palindrome and pass this number, whatever we add it there, and we run this, and it's gonna do, let's say if I say 1, 2, 3, that will reverse is 321. So it will gonna say, oh sorry, oh right. Oh, because I misspelled the palindrome, right? So this is a palindrome, so I have to make sure I use the same. I need to do this, and I need to use the same spelling, right? This one. If I say here, I should say is palindrome, like this. If I do that, that should be okay, right? So now I say 1, 2, 3, and see Duncan Donut is good. Why? Because it's not palindrome. If it's palindrome, it would be, see, if it is palindrome, it will be here equal, right, to this reverse number that we found out, and the number will be equal. But if it is not, then it's gonna, so it's gonna only say Starbucks when the number is palindrome. So tell me what any a palindrome number. So I think the palindrome number is 1 to 1, because if you reverse it, that's still 1 to 1. So it's gonna now print coffee of Starbucks is good. There you go. See. Similarly, 99 is also palindrome number. If I do 99, yeah. What about 9? 19 is not, that becomes 91. Yeah. So it's gonna say Duncan, right? So this is the end of the question. I hope you understood it, right? So this is how you programmed it. And now we're gonna move to we're gonna refresh it. We're gonna move to the next question, and that is actually question number 8, right? This is the question number 8, and this one is finding a different. Now we're gonna go to another formula, right? These are intense formulas, right? So this one is, let's copy the question, right? Question number 8. This one is pretty simple. It says write a program to check whether a number is Armstrong or not, right? So after that, if the number is Armstrong, then print message coffee of Starbucks is good, else print coffee of Duncan is good, right? So first you need to check if the number is Armstrong or not. Now, before we do that, we need to understand what is an Armstrong number. An Armstrong number is a number if you use the rate. For example, let's say, I'll tell you here. Let's say 19. If you want to find out if 19 is Armstrong number or not, what we have to do is we have to first see how many digits are there, right? There are 2 digits. So what I'll do is I'll say 1 raised power 2, yeah, plus 9, right, raised power 2 as well, right? So what is 9 raised power 2? 9 raised power 2 is 18, right? 18 plus 1 raised power 2 is also 1. So 1 plus 18 is equal to, trust me, I didn't know it's an Armstrong number, but apparently 19 is an Armstrong number. Oh, wow, bingo. That is an Armstrong number. So see, this is 19 is equal to 19. So this 19 is an Armstrong number. What about another number? For example, if I say 20, 20 is an Armstrong number. How would I know? I would say do the same thing, 2, because there are 2 digits. To 2 raised power 2, which is 4, plus 0 raised power 2, which is 0. Okay, 4 plus 0 is equal to 4. Okay, and that is not an Armstrong number because 20 is not equal to 4. What about 153? Is that an Armstrong number? 153. So here we need to do, what we need to do is we need to, how many digits are there? 3. This time we have to power by the, because the power is always number of digits. So if there are 3 digits, then you have to power every single digit with the 3. Okay, yeah, 5. Okay, and then that's also 3. Okay, then 3 raised power 3. 3 raised power 3 as well, right? Now if we do this, that will become 1 plus 5 raised power 3, 5 times 5 times 5 is 125. Okay, and 3 raised power 3 is 3 times 3 times 3, and that's 27. 3 times 3 times 3, and in total, if you add 1 plus 125 plus 27, that is equal to 153, right? And if you look at it, 153 is equal to 153, so that is an Armstrong number, right? So similarly, if you have this number, let's say 1, 4, 4, 5, how many digits are there? First we need to find out the digit. 1, 2, 3, 4 digits. So every digit has to be raised power 4 and added together, right? So 1 raised power 4 added 4 raised power 4 added 4 raised power 4 added 5 raised power 4, 5 raised power 4. So sorry, I can't even write with this one. So first you have to find out the number of digits. So let's write this program to find out an Armstrong number, because it was important for you to first understand how the Armstrong number works. So here we're gonna start up with this, right? We're gonna start up with this. We're gonna say def is Armstrong, Armstrong, and we pass a number to it, right? And then we're gonna check if that number is Armstrong or not. So when you pass a number, first thing you need to do is you need to convert that number into string, because that number you pass may be an integer number, right? Because you're not gonna take it from the user, you're just gonna pass it. So you wanna make sure it is converted into string, str. Okay, str, because only string number. And then why string? Because you want to find out how many digits are there. For example, if you say 153, there are 3 digits. So there is a string function and it's called length. So you can find out. The reason we converted it to string is we just want to find out how many digits are there. Okay, len, and we pass number string to it, and this will tell us the length. So for example, if we pass Armstrong number 123, the number digit will be 3. If we say 12, it will be 2. If we say 9, it will be 1. So length give you the length of the number. So let's say number is 2304 or 45, 2345. These are 4 digits, right? So this function, for example, here I say this one. How many are digits there? Yeah, 4. So when you pass it here, it becomes a string, and then you call a length function, it'll give you 4, because these are 4 digits, because we need to raise power every digit with 4 if it is this is the number, right? Now next thing what we need to do is we need to go with the for loop. First we need to set the Armstrong number sum is equal to 0. Armstrong sum, because we need to add every single number with after raising power, so we're going to set it to 0, and we're going to say C for digit, okay, in number underscore str, right? So this will run for digit in number. So if digit, I mean whatever the number is, because that's a string, so we're running it. So first time it will run for, let's say if I enter 134, the first time loop run, the digit will be 1, the second time loop run, digit will be 3, and then the 4. Okay, that's why we gotta run on the string, right? Because it's a string number. And what we do after that is we say Armstrong sum, right, equal to Armstrong underscore sum plus, okay, and then what you're gonna do is you're gonna say integer, and here you're gonna do digit, right, and here you're gonna multiply by power by. So Armstrong, whatever the Armstrong is, you in the loop you want to pick up every single digit and add to it after raising the power of digit to what? To the number digit, right? So number digit is the total length, by the way, number digit. So and then it's gonna continue. That's it. This is it. The whole formula of finding an Armstrong is on this one line. How? So let's say if I pass here 131, if I pass 131, okay, what would happen is this number digit will be set to 3, because there are 3 digits in it, right? 3 numbers is equal to 3. Now sum is equal to 0, and digit in string, the first time when the loop run, the digit will be 1, right? So you say sum is equal to Armstrong sum, which is 0, right? 0 plus, okay, and what is the first digit? 1 raised power what? 3. Why? Because the number digit is 3. So 1 raised power 3. What would that be? That would be 3, right? And now the Armstrong number is, instead of 0, it is 3 now, right? And then you come here again in the loop, and the second time digit would be 3. Now 3 raised power 3 is 9, and there's already 3 plus 9 is 12, right? 12. And the third time loop runs, the digit would be 1 raised power 3 is again 1. Sorry, my bad. 1 raised power 3 is 1, not 3. Okay, 1 raised power 1 is 1 plus 12 plus 1, that would be. Alright, let's do it again. I'm sorry, I think I confused you. So let's pick up this time an Armstrong number. Let's say 1, we pass, imagine we pass 1, 5 and 3. I'm sorry, I wasted your time. I apologize for that, but I'm gonna get it clear now. Okay, this goes into this one, and then this line converted into a string. Okay, and then number digit is gonna give you number of digits. How many digits are there? 1, 2 and 3. So number digit will be set to 3. If this was 4 number, then it will be 4. Armstrong is 0, right? Remember that. And for digit in number string, so when this for loop run, the for digit mean first time digit will be 1. Okay, because every character of the string this loop will run on, because this is now being treated as a string, right? So first time digit will be 1. So we'll say Armstrong, which is 0, 0 plus, right, 0 plus 1, because integer digit would be 1 raised power. What is number digit? Number digit is 3. I remember I told you this 3. So 1 raised power 3 is what? 1. So this sum will be set to 1 instead of 0. The second time loop run, the 5 will be the second digit, right? So you're going to pick up second digit. Now Armstrong is 1, sum is 1 plus 5 raised power 3. What is 5 raised power 3? That is basically, because this number digit will be 3. So that is 125, isn't it? Yeah. So 125, 5 raised power 3 is 125. So 125 plus 1 would be what? 126, right? 126. Yeah, this would be the Armstrong sum now. The third would be the 3. So then digit will be 3. So the third time when it runs, it will be 126 plus 3 raised power 3, right? So what is 3 raised power 3? That is 3 times 3 times 3. That is equal to 27. So now 126 plus 27, what is that equal to? Yeah, that is equal to, my friend, 153 exactly, right? Now the loop will finish because it has done. So this digit that we passed, we raise it power with the number of digits, which is 3, 1 power 3 plus 5 power 3 plus 3 power 3, and that is equal to 153. And if it is equal to its own value, then this number is an Armstrong number. So this 153 is an Armstrong number using this formula. All we need to do now is we need to check if the Armstrong sum is equal to the actual number, right? And obviously we need to convert it into integer to check it. And that's it. If that's the case, right, it will return true, right? If that's the case, it will return true, right? And else it will return false. And now we need to pass an Armstrong number. We can take an input from the user, right? And we can just pass and check. And we remember that coffee thing we need to print. If it is Armstrong, we say Starbucks is good, and if not, then not. So we say number integer, right? And we say input, okay? And then we say enter a number, right? Number, right? And then we say if is Armstrong, and we pass the number to it. If that is the case, then print what? If it's an Armstrong, because if it's Armstrong, it will return true. Remember here this line, right? So then it will print what? It should print the Starbucks is good, right? If it's true, it will print Starbucks is good. So we're just gonna do this one here. It's gonna do Starbucks is good if it's true, and if it's false, it's gonna do the coffee of Dunkin' is good, right? Else it's gonna do print, yeah, coffee of Duncan is good. That's it. That's our program. So let's do it then. Let's see to get rid of some errors. I'm sure there are going to be some errors. I can tell you from here. This is an error. Yeah. And then I don't see any other error. Yeah, apparently fine. No, there is double equal. Ooh, instead of this single equal. Which line is that? That is line number, I need to see the line number. That's line number 12. Line number 12. This one. Double equal. It has to be double, because if it is if command, it has to be double equal. Now it's working. So it says enter a number. So we enter a number, let's say this time 153. Now 153, when you raise it power by 3 each digit and add it together, that is also equal to 153. So it will print coffee of Starbucks is good, because that is an Armstrong number. Ooh, we got an error, or maybe digits. Okay. Number digit. Oh, right. Okay, I'm sorry. Ooh, right. Number digit. See here, number digit. This is a spelling mistake here. This is number digit. Digits, not digit. Right, like this. Okay, 153. Starbucks is good. Ooh, again. Armstrong sum is not defined. See, when you don't, you must copy paste. Otherwise, you make these errors. Armstrong sum. And Armstrong. Which line is that? 17 and 12. 12. ARMSTRONG underscore sum. Okay. Okay, that's fine. Is equal to integer number. That's okay. And here we say Armstrong ARMSTRONG sum is equal to Armstrong sum. So what is the problem there? Not defined. Sum. We did that here. Is Armstrong sum is defined here. Armstrong sum. So best is to copy this and paste it everywhere, so that you don't make any mistake with the spelling or anything. Yeah, like this. Like this. One, 5, 3. Ooh, here you go. See, it worked. So coffee of Starbucks is good. But if I put here, let's say 1, 2, 3, which may not be an Armstrong number, so it's going to say coffee of Duncan is good, right? So this way, this function is all done, my friend. I hope you enjoyed this. So let's move on to the next one then. Okay, so now we are going to do question number 9, right? So what is question number 9? Question number 9 is also about Armstrong, right? And this is simpler question. So this time we only have to print Armstrong within a range. We don't have to do Duncan or whatever. We just need to find an Armstrong number between 0 and 100. So what we need to do is, remember that what we did with the for loop and digit, right? We have to keep it same. So, but we just need to pretty much same, right? Pretty much same. But this time we're gonna print it within a kind of like, loop, so that we can print the whole thing. Same answer, right? Exactly same answer. What was there in question number 8? Nothing changed there, right? So we're gonna copy paste the same what was in question number 8. This was the question number 8, isn't it? This one what we did, right? Remember that question number 8, we did this. Yeah, exactly same, no change there, right? Because it gives you true and false on Armstrong. What you did in question number 8, exactly same function. The only difference is you have to when you call this function, you want to call it instead of let me actually do what we did in question number 8, right? And then we change it to print Yeah, this is what we did in question number 8, right? This is question number 8, right? So let's call this one in the question number 8 and try it 153. Remember that a while ago I did that in the last video? No, 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 no. Which line is that? 19? Oh, this one here. Okay, here. This is question number 8, by the way. Okay, we're going to change question number 8 to question number 9. Let's see, 153, it says coffee at Starbucks is good because 153 is the Armstrong number, right? And if we say 100 and 1, 2, 3, this is not Armstrong number, it's going to say donut is good. So, and every time there is a Armstrong number, it's going to basically print Starbucks. So what other number is the Armstrong number? We have to find out between what? Between 0. In this question, what it says, write a program to print Armstrong number from 100 to 2000, right? Between 100 to 2000 we have to print it. So all we have to do is keep this function as it is, which I explained in question number 9. We don't need to do anything to it, right? Only thing we'll change is we don't need to take the number now from the user, right? This is where we make a change. Okay, instead of taking the number from the user, right, even this one is going to, and we just need to print the number if it is Armstrong number, right? That's it. If number is Armstrong, we just print the number. We don't say coffee is good. We just print the number is good, and then we just need to print it, and this is gonna print only one number, right? If you run it, let's see, if I say 153, it will print 153 because it's an Armstrong number. But if I say 1, 2, 3, it will not print it, right? So all I need to do is I need to run the number between using for loop. I'll say for, right? For and number in range. So I need to give a range there, right? Between what? Range would be between 100 to 2000, because look at the question. It says print all the Armstrong number from 100 to 2000. So here all I have to do is I have to print all these numbers. So I'll say for, okay, and I'll get rid of this, right, because this time I'm going to do this for number in range, right, and it's going to start from 200 comma 2001, because if you want to print check all the number up to 2000, we have to give one ahead. I told you that in for loop already. Otherwise it is going to go up to 199. So if we say 2001, it will go up to 2000. Start from 200 and 2000. And now any number that is Armstrong number, where it will return true here, right, in the last function that we wrote in question 8 as well. So this is the same function. I keep saying that. And this will print that number if it is Armstrong number, right? So let's see what are the Armstrong number between 200 and 2001. 2000 actually. Run this, and I got an error. What is the error? There's indentation, because there's a for loop, so this time you need to move it above like this, right, because it has to be indented like this. Here we go. These are the Armstrong number, my friend. These are the Armstrong number between these are only 4 Armstrong number between 200 and 2001, and those are 370, 371, 407 and 1634. Let's say if I change it here from between 100 to 2001, now it will add another number. Remember that 153 is also Armstrong number. If I change it here between 100 and you see here this between 100 and 2000, now it will add another one which is 153. So it will say 153 on top, and then it will say 370 to 371 and all these 4 numbers. So it will be total, it will be 5. Let's see that. Let's run this. Here we go. See, this is 153 added on top, because that's between 100 and this. So this is the simple answer to this. In the exam, only thing I probably will change is this number range, right? In the question I may say write a program to print Armstrong number from, let's say, 500 to 5000, right? So what do you have to do? You have to change only here, You have to say 500 to, if I say 500 to 5000, if I say here 5000, right, like this in the exam, and here I say 500, right, what do? You just put here 500, and instead of 5000 you say 5001, and it will print all the Armstrong number between 500 and 5001. And that is, my friend, only 1634 is the only Armstrong number between 500 and 5001. I hope you enjoyed this, because question 9 was pretty easy, wasn't it? I mean, we just had to understand question 8 and only change these 3 lines, and that becomes question 9, right? That's the only difference between 8 and 9. So that's both questions are same on the more or less, but you just need to understand the difference between them so that you can do it. Now, this is the last question of this video, because in each video we're doing 5 questions. So I'm gonna do this last question of this video, and that's about the harsh number. So I'm gonna rerun this one like this, right? And I'm gonna write down a question here, and that is about the harsh number, right? Harsh number. Okay, so what is the question then? Oh, question is simple. Write a program to check whether number is a harsh number or not. So what is the harsh number? Harsh number is a number that is divisible by the sum of its own digit, right? That's a harsh number. That's it. That's how simple the question is. We just have to find out if the number is a harsh number or not. So let's say if we have to find a harsh number, let's say if a number is passed and it's, let's say, this one 100 and let's say 56, right? We want to check if it's a harsh number or not. Simple formula is that if the 166 divided by its own sum of its own digits, what is sum of its own digits? 1, 5, 6. 1 plus 5, 6 plus 6, 12. So if it is divisible by 12, right? And when I say divisible, it has to be fully divisible, right? It cannot be just divisible with the remainder. No, fully, completely divisible. So what we do is, I do kind of calculator here to help you out, right? So here we are. So if I say here 156 divided by 12, does it give me any remainder or fraction number? No, it's 13, right? So that means 156 is a harsh number, right? That's the harsh number. Simple. Right, now let's write a program to find that in the Python. And we always say is harsh, harsh number, like any other thing, number. Here we go. And then what we do is we convert, because we're going to play with the number, so we're going to convert it into a string, right? str. And how do we do that? By just we say equal str, and here we say number, right? And next we have a digit sum. Because we're gonna whatever the number is, 156, we're gonna add 1, 5 and 6, so we're gonna get a digit sum. So I'm gonna have it set it to 0 so that we can actually use it. So what we do is we say digit in what number. Remember the same sort of like number string, it's the same as the previous question we did, right? So it is gonna add, if you enter 1, 5, let's say you enter 1, 5, 6 as a number. So what we want to do is we're gonna add 1 with 5 with 6. So this function, this one, is gonna do that for us, right? So let's write it. So we're gonna say digit underscore sum is equal to digit underscore sum plus integer. We're gonna convert it into integer, isn't it? Digit. What is digit, by the way? I'll tell you what digit. So this is it, right? And all we have to do is we will get this sum of the digit, and we just need to check if number percentage digit underscore sum is equal to 0, right? I mean, if they are divisible by each other, then it is basically, what is that then? That is the we return true. That's it. True mean that is the hash number, right? And then we just need to call that function, right? And we can, because this question does not really say that you wanna take an input from the user or not, so you can do whatever you like, but I'm gonna take an input from the user. So then what we're gonna do is we're gonna say number is equal to integer, okay, and we're gonna do input and we'll say enter a number, right? Enter a number like this, right? Here we go, enter a number here, and then we're gonna print if right, if it return true, if is hashed, right, return true, and you pass this number to it like this. If it return true, then you say it is a hash number, right? The number is, what you print the number is a hash number, okay? The number is a hash number. Now let me explain you this, right, how it works. First I'll run it and then I'll explain it. So let's say because 153 we know is a hash number, so let's see how it works, right? I put here 153 and it says it's a hash number, right? And if it is not a hash number, then what it should say? It should say it is not a hash number. So we're gonna put the else part as well here, right? Else print it is not a hash number, right? The number is not a hash number, right? That's it, right? So now I'm gonna run this and I'm going to explain it to you. Let's say if it's 1 2 3, it is not a hash number, so number is not a hash number. So how does it work, right? Let's do this, my friend. Let's do 153 and check. Oh, this is a hash number. So when I enter 153 here, right, that went into the number here, so it converted into a string number. So now 153 is a string number, right? And then I ran this for loop on it, on this string number. So we say for digit in number string, which means the first time when the loop run, the digit would be 1, the second time loop run digit will be 5, and third time loop run digit will be 3, okay? So we say digit sum, which is set it to 0, right? And we say digit sum is equal to digit sum plus integer digit. So first time the digit will be 1, it'll add 1 0 plus 1, okay? And then it will run second time, the digit will be 5, it will add 5 to it, right, to the digit sum. And third time loop runs, the digit will be 3, so it'll add 3 to it, okay? And this way we'll have what? Digit sum value equal to 12, right? We'll have 12. And when the 12, now we need to check if the number remainder 12, what is the number? Number is 153, remainder 12, because 12 is the digit sum, this one here, is equal to 0. If it is equal to 0, that means it's a hash number. So when you 153 divided by, sorry 100, this is not 1 5 and 3, if you add it together it's not 12. Why I said 12, I'm sorry. 1 plus 5 plus 3, that's 6 plus 3, 9. So that's 9, not 12. I'm sorry, my bad. 9, right? 9. So now you're going to do is 153 divided by 9. And if it is remainder is 0, which is, by the way, because when you say 153 divided by 9, you get 12 as the answer, okay? And that remainder is 0. So that means it is a hash number, right? And it give you this, it will print it is a hash number when you run it. That's why it's printed as a hash number. Let's do this same thing for another number, right? This time we do it for, let's say 1 2 3, right? Not 1 2 3, let's say do it for 100, or maybe 120. Let's do it for 120. 120 is also a hash number. Why? Because 1 plus 2 plus 0, which is equal to 3, yeah, And when you divide 120 by 3, remainder is 0. That's true actually, because answer is 40. 40 multiplied by 320. So it is a harsh number, right? Let's pick up a non-harsh number. Let's say we say 1 to 1. That is not a harsh number. Why? Because we do it here again. We say 1 to 1. Is it a harsh number? What I have to do is we have to add these three together. So this one is gonna add this together for us, all of it, and give us 1 plus 2 plus 3 is equal to all these three added together. 1 plus 2 3, 3 plus 1 4. If you divide 123 by 4, remainder is not equal to 0, because you cannot divide 123 by 4, and that's why this here will not be true. It will not return true. So that's why it will print that number is not a harsh number. So that's how simple this is. I hope you understood it. Thank you very much for watching. It's been very intense. Whew. Because we solved some of the very difficult questions in the exam. Thanks for listening. And next video I'll do the next 5 questions. Thanks.